Good afternoon again. Last time I started with the disadvantage of you guys coming in after lunch, but now you had coffee, so I think I'll be able to survive. Okay, and now I'm going to talk about OpenShift Enterprise. OpenShift Enterprise is Red Hat's platform as a service offering. How many of you here know what PaaS is, platform as a service is? Okay. For the rest of the folks who don't know what PaaS is, platform as a service is an abstraction above infrastructure as a service, giving developers an interface they are comfortable with so that they could just write their code and push it easily so that they could meet the needs of their users. It's an abstraction at a higher level. It adds some of the cloudy features to at a layer above infrastructure. With infrastructure as a service, IT got the self-service, easy management option, elasticity and all that. So at the infrastructure level, they could easily deploy virtual machines. They could easily scale it up, bring it down, and take care of everything. But to give developers an easy interface, they need to resort to using certain tools like Puppet and Chef, sort of build a complex environment and then give an easy interface to developers. That is definitely a good way of doing things. It helps in certain cases, certain use cases, but there is even a better way to do it, like by sort of not going up a notch, automating middleware and application lifecycle management tools, and putting the abstraction over there. Instead of just having the abstraction at the infrastructure layer and doing everything above that in a much more complicated way. How about standardize at a layer above middleware at the application lifecycle tool level? So that's the idea behind platform as a service. And OpenShift is Red Hat's offering in that space. We have OpenShift Origin, which is our upstream open source code base, where all the development happens. Then we take it to OpenShift Online, which is our hosted offering, which is the public PaaS version of OpenShift. Then after that, we sort of tighten the code and make sure it works well for the enterprise needs and bring it and deliver it to enterprises for on-premise PaaS. That is OpenShift Enterprise. So as I said, a platform as a service is an abstraction at a much higher layer, making the application scaling much more seamless than what you can achieve with the infrastructure as a service. Let's take the case of infrastructure as a service. If you want to scale applications, one way to do it is like rolling out additional virtual machines which could bring up that application and load balance across all those virtual machines. That's one way to do scaling. That is basically like achieving scaling through scaling of infrastructure. But that is not an efficient way to do it, because if you have to bring up a full virtual machine to meet the additional load that is coming in, it's not very efficient. So you need to find a way to make it much more efficient by abstracting at a much higher level and then scaling. Let's say instead of standardizing on virtual machine, you go up a notch and standardize on what we call as containers. It's an abstraction above the traditional hypervisor-based virtual machines and makes it much more efficient. So platform as a service is a cloud application platform where developers come in, code, push their code in, and magic happens. Users could just check out the application. It scales up, down based on the needs. So it's a pretty easy way for deploying applications in organizations. Today's IT challenge, as I told in my previous talk, they are under tremendous pressure to meet the needs of businesses. And also with the mobile and sensors and all sorts of things coming in IoT and other things coming in, there is always a demand to bring newer services, mostly coming from the consumer side of things. So developers want to build modern web services and modern mobile services, all sorts of things. And IT needs to meet the needs of developers. So, and also there is constant pressure from business to speed up and accelerate the time to market so that they can compete hard in this globalized economy where if you don't take advantage of the modern tools that's available in the market, your competitor will. So you need to handle the needs of business users and offer a platform that makes it easier. So in the traditional world, this you must be familiar with the process I have outlined here. In the traditional world, whether it's a physical infrastructure or a virtualized environment, you need to go through a lot of manual processes to get your code to production. So of course, virtualization sort of cut down on the number of processes you need to go through. But how about taking it a notch higher? How about like you have a budget, you have an idea. How about building a platform that makes it easy for you to deploy the code to production? That's where PaaS comes in. With PaaS, you take the idea, get the budget, test it, and push it. It's available. Boom! It's a magic. All the magic happens underneath. Of course, it's much more complex out there. But the abstraction makes it easy for developers to not worry about the complexity and deliver applications at a much faster rate. Essentially, PaaS increases the velocity of IT. PaaS makes it easy to develop applications faster, which in turn helps increase the revenue for the entire organization. And of course, as I told, if you don't use the modern tool and give developers modern platforms, your competitors will be giving them, enabling their developers. So not using PaaS or other modern technologies could become a competitive disadvantage. So it helps in the competitive advantage and it helps meet the organizational goals much more easily and rapidly. As I said, with the virtual machines, you achieve certain level of efficiencies. But working with virtual machine increases operational complexity and makes it less efficient. Also, virtual machine takes a long time to come up and serve based on needs. So, and also you could pack only certain number of virtual machines in a server, but with the abstraction at a higher level, you might be able to pack more. So, infrastructure as a service gave the self-service capabilities to the IT admins. How about giving similar capabilities to developers? Of course, infrastructure as a service helped IT admins streamline their operations. How about making it much more easier for developers too? How about making it easier for developers to just go get the code and push it to a RESTful or interface or something like that, and everything happens magically after that. So that's where PaaS comes in. It increases the efficiency and makes IT much more useful in today's context. There is a talk about PaaS making operations go away. That is not the right way to look at it. In fact, PaaS makes operations act at a much higher efficiency. It's like we used to do simple scripts. We used to use simple scripts to do automate some of the system admin tasks. So then CF Engine, Puppet, and Chef came in. It made the same operations team operate at a scale. With the needs of business users increasing today, with the pressure on IT to operate at a much higher scale, and with the economic pressures not letting the organizations to spend more on IT, you need to find a much more efficient and smarter way to do IT. That's where PaaS comes in, and it doesn't take away operations. Rather, it makes operations much more efficient and strategic. And with PaaS, scaling is much easier. As I said, with infrastructure as a service, you could scale by bringing up more and more virtual machines. But there should be a better way to scale applications. So PaaS brings in that kind of application scaling, which is key to the very definition of PaaS. I will come back to it later. And it also scales your workflows and processes. OpenShift is the platform as a service offering by Red Hat. It is a polyglot platform. When I say polyglot, it supports more languages than ever before. As you asked, like it goes beyond Java, which is still our strongest point, because we have JBoss as a part of our EAP as a part of our product. But it also supports other languages like Ruby, Python, PHP, and a few others which I'll talk about later. So it has auto scaling. This is a key point which you should remember when you go out and look at PaaS offerings in the market. There are many PaaS offerings out there in the market. Some of them do scaling only by scaling the infrastructure. Whereas OpenShift is one of the few which does scale applications inside a single virtual machine. For example, you could have multiple instances of applications running inside a single virtual machine. You don't have to bring up two virtual machines to have two instances of the application running. You could have it within a single virtual machine. That makes OpenShift one of the efficient PaaS offerings out there in the market. And it offers self-service to the developers. There is a web console, there is a RESTful interface, and you could also use command line to push your code. So, of course, as it is the case with any of the Red Hat's offering, it is open source. Well, as I mentioned before, we have OpenShift Origin, which is our open source code. Then we have OpenShift Online, and we have OpenShift Enterprise, which is enterprise ready, which is enterprise grade. So it is also secure. It runs on top of Red Hat Enterprise Linux, which is one of the most secure operating systems in the world. So that makes OpenShift one of the secure PaaS offering available in the market. We have won many awards, including Cody Awards, and in fact, in a recent Linux Foundation survey, developers preferred OpenShift over competing offerings by a margin of 20%. So we have a pretty popular platform, and Gartner picked Red Hat as one of the vendors in their top quadrant, top right quadrant. And another interesting thing about the Gartner Magic Quadrant is we were part of both the private PaaS quadrant as well as public PaaS quadrant. I don't think many others in the market could make this claim. So clearly OpenShift has been established as one of the best platforms out there for developers. And analyst firms like Gartner recognize this by putting us in the Magic Quadrant. Okay, I gave a brief introduction to PaaS and spoke about what is OpenShift. Before I go into the technical details a little bit, let me talk about how some of our customers are using it. You might have heard about the company called Cisco, which is it is one of the largest network equipment manufacturers in the world, and they have a large virtualized server farm. They have to deal with several thousand developers who wanted to develop Java applications. So they wanted to automate everything and offer a self-service interface. So they picked OpenShift because it offered them a standardized development environment which they could push it to development, testing, and production. And it runs on top of standardized stacks. That is one thing which Cisco was very happy about, because it's not something, we are not using any proprietary stack to sort of make it much more useful for developers. It's running on top of open source standardized stacks. It runs on top of one of the industry leading operating system. So these things worked in our favor, and Cisco is one of our largest customers. And they also like the technical depth which Red Hat provides. I think Damien pointed out this thing in the morning. We really support our platform with the technical expertise so that you don't have to worry about any of the complexities. And there is a leading financial service provider called FICO. They also had similar requirements, but interestingly, they are an ISV from the traditional world who wanted to SaaSify their application. And they also have on-premise offering. So they wanted a platform which they could use to make their application SaaS as well as if they have to serve one of their customers by installing their product on premise, they need a easily portable platform. OpenShift helped them because it had a pretty solid feature set and easily portable, and it gave a API interface which helped them integrate with some of their product. So these customers love OpenShift because it's one of the most flexible and powerful platform that's available in the market. I hope I made a case for OpenShift and why it is a pretty interesting platform in the market. So let me go a little deeper into it and talk about the technical architecture. As I said, a PaaS offering like OpenShift should allow developers to write code, push it in, and serve their users. That's what OpenShift does. OpenShift runs on top of Red Hat Enterprise Linux. So OpenShift can technically run on top of anything, wherever Red Hat Enterprise Linux runs. Bare metal, or traditional virtual environment, or any of the private clouds, OpenStack and others, or any of the public clouds where you could run RHEL. And so this is basically OpenShift is much more versatile in terms of running on different infrastructures. So that is one of the biggest advantage for OpenShift. You are not dependent on the vendor for the infrastructure. You could plug into any infrastructure which you have right now. It could be even just a bare metal server without any cloud like elasticity. OpenShift will work. The foundation of OpenShift is Red Hat Enterprise Linux. It makes OpenShift much more portable, and it makes OpenShift much more secure, because RHEL is one of the secure operating systems in the world. So it makes that is what makes OpenShift much more appealing to the enterprises, because enterprises have a wide variety of environments. Like they might have some bare metal servers, some virtualized environment. They might be embracing cloud. So how come you have a platform that could work across all these environments? So OpenShift helps them because it runs on top of RHEL. So if you want to, I'm going to briefly touch on the technical architecture side. I'm not going to go deep on that, but just wanted to give you an idea about how OpenShift works. The key components inside OpenShift are called brokers and nodes. Broker is like the brain, like it's the orchestration and management engine which handles all the nodes. Nodes are like node is an instance of Red Hat Enterprise Linux, inside which you could run your applications. Inside a node, we run applications using a kind of virtualized setup called gears. It's nothing but Linux containers. So you could pack the applications and its dependencies on a gear and push it to the node. Since we could run multiple gears inside a single node, we could offer the application scaling I was talking about. You don't have to scale up or spin up additional virtual machines to scale. You could scale, you could better use the virtual machines you are using to the maximum, and then spin up additional virtual machines if needed. So this the efficiency offered because of this kind of application level scaling makes OpenShift much more versatile in dealing with the needs of modern enterprises. As I said, we pack applications inside containers called gears. So that offers multi-tenancy. So since our containers use RHEL, it offers the isolation. So if you are running more than one application inside a single virtual machine or inside a single physical machine, they are isolated in such a way that there won't be any impact. For example, if I am a public cloud provider serving multiple customers, you don't have to worry that some code run inside the container will by some other customer will impact yours. So RHEL offers that isolation, which makes OpenShift much more secure. So traditionally, from a developer point of view, I think there are many developers out here. As our friend said in the last talk, developers want to avoid complexity. They want an interface which will make their code run seamlessly. That's what OpenShift provides. From a developer point of view, they write the code and push it to OpenShift. OpenShift in turn puts that application into a gear, and you could use either the REST interface or the web console to create a gear, and it seamlessly scales based on the needs. So gear is where we package our applications and the dependencies. So we support the dependencies using something called cartridges. I understand the different terms used here could be a little confusing, but think of it this way. Node is like a virtual machine. Gears are containers inside virtual machines, which could encapsulate application and its dependencies. And cartridges as another subsystem that just encompasses the application dependency. When I say application dependency, for example, the language runtimes and middleware frameworks your application needs can be plugged in through Gear. It's not just the language runtimes and middleware. We also support databases through Gear. It's not just databases. We also support third-party services through cartridges. So the cartridges is some very flexible format which lets you easily plug in the application's needs in a seamless way. In fact, the OpenShift has a very open architecture, giving developers an environment which they can customize to meet the needs of their application. For in the initial days of PaaS, developers have to change the way they code to make the application run on a PaaS environment. Whereas OpenShift, it gives that flexibility to developers. Depending on the dependencies that are needed for your application, you can select those cartridges that should run inside the gears. So that makes OpenShift a powerful platform. So for our cartridges, through cartridges we support the third-party providers, and we have a pretty solid partner ecosystem. For your Hadoop needs, you could use cartridges provided by Hortonworks. Then we have also support some of SAP's databases like SQL Anywhere and SAP IQ. Then the cartridges are standardized so that even competing PaaS providers like Jelastic are using it to support their application. So if you use a particular cartridge for your application on OpenShift, you could easily port to Jelastic and run it without any complex changes. So same thing, if you run something on Jelastic, you could easily port to OpenShift. That makes cartridges sort of standard in the industry. And we are slowly moving to Docker, which is the new format that supports Linux containers. We are embracing that. We are also partnering with Google on Kubernetes, which is the orchestration engine for next generation of platforms. So in our next release of OpenShift Enterprise, we'll be supporting Docker and Kubernetes. Right now it's available in the open source code, but the enterprise will have sometime later in the year.
So Docker and new gear?
And yeah, Docker is the format we use to spin up new gears. We use Docker and Atomic as Atomic is the host operating system. So we use the Docker format to spin up the new gears. So essentially, OpenShift gives an easy interface for developers to just write the code and push it out. And everything else happens automatically underneath. We handle it with gears, cartridges, and all that. And that is going to continue even after we move to Docker. It's not going to affect our users in any way. So by embracing Docker, OpenShift is one step ahead of every other platform as a service provider. And with Docker, the portability is much more seamless. So OpenShift is going to become only platform that makes portability of application a possibility. So we talk about portability often in the media and other places. Nobody actually does it well. And with by supporting Docker, OpenShift is in the process of doing it. So when I was talking about DevOps, I was talking about standardizing environments across different teams, from development to QE to production. OpenShift makes that easy. So with OpenShift, you could have the deployment pipeline, which is standardized and automated. So you could embrace DevOps in a much more seamless way with OpenShift. Of course, as I told before, OpenShift handles application scaling, and we not only you could scale infrastructure easily by connecting to one of those cloud management platforms, whereas OpenShift makes scaling of applications within a virtual machine or across multiple virtual machines much more seamless. So in short, the platform as a service in general and OpenShift in particular makes IT service delivery seamless, and it helps organizations become more agile and embrace DevOps much more naturally. I talked about OpenShift being a polyglot platform, but on the enterprise side, you have Java developers, you have some small segment of developers who do coding on Ruby, Python, and other things. But there is a significant chunk of developers doing .NET. So we need to support them. We are originally a Linux company, but our platform is so flexible and we believe in openness. We also added support for .NET through one of our partners. So you could technically run your .NET applications on OpenShift. So it is available through our partner called Uhuru Software. And with the same management console, you will be able to manage your Java apps, Ruby apps, Python apps, and .NET apps. It's a pretty powerful and seamless platform. So far, I have talked about application deployment. Application deployment is not just writing the code and pushing it out there. You need to sort of think about integrating with the higher order services and possibly using something like an identity service or talk to multiple data platforms and all that. To support that, and we are, as Ken said in his previous talk, we have a very powerful middleware portfolio. How do we support that middleware portfolio with OpenShift? That's where XPaaS comes in. XPaaS is our higher order services supported on top of OpenShift, about which Ken will be talking in the next 30 minutes. If you have any questions, feel free to ping me either after the talk, after Ken's talk, or through my coordinates listed here. Thank you.
Thank you, Mr. Subramanian.